Hi everyone, today is December 15th and welcome to the Lifecycle Working Group. We have two topics on the agenda. So first things first, does anybody want to introduce themselves?
Hi guys, my name is Ebenezer. I'm based in Nairobi, Kenya. This is my first time here. Uh, yeah, I'm an intern on the SRE team at Safaricom, and yeah, I'm looking forward to hearing how contribution to communities happen. Thank you, and back to you.
Cool, welcome.
Hey everyone, I'm Lalit. I'm the maintainer of NV Sentinel. So I also work at NVIDIA. So some of the work that we've been doing also intersect with what the Node Lifecycle Working Group is also doing. So I kind of want to listen in and see where we can help best. Thank you.
Great, thanks. Okay, so let's kick it off. We have one organization item. So we have upcoming holidays and we will cancel, I think, the next two meetings. And we will see what kind of items we have at the start in the January, and we will decide if we will, yeah, if we will have it or not. Okay, so I have the first item. It's about the eviction request update. So at KubeCon, we decided to make a couple of major changes to the API, mainly to simplify it, and so we can easy push this forward in a faster and more iterative way and add additional features in the future. So I will just quickly go through those to see if we have any feedback on these, and I would like to discuss mostly the scheduling proposed changes. I mean, follow-ups. So let's see. Yeah, we can just go through these commits. I try to name it. So we can just read it. And so first thing is we decided to make the eviction interceptors immutable. And this is so we can better describe or go through the use cases. And together with this, okay, let me show the API first here. Okay, so we had two interceptors. One is on the pod itself, and the second is on the eviction request. And originally we could mutate the pod requesters or interceptors before the eviction request was created. So we decided in the beginning that we just want to add this feature for the controller creating the pods and decide on this later. And we do not allow adding new interceptors when the eviction request is created. So for example, by a admission webhook. So this is mainly for predictability reasons. So all the actors or uh, entities observing pod specs can actually know what will happen during the eviction. So they can predict the behaviors of the interceptors. I will go to the the observability point a bit later when we discuss the scheduling changes. And yeah, and so we removed also the priority and role fields. So the interceptor now is very simple. We just have the name, and we saw that the ordering problem of interceptors is a difficult one, and it's it makes the cap more complicated basically for alpha. So we will return back to this, and we just now will use the order of the interceptors that's set in this list of the pod spec. So I edit I have a description above, that says that basically the interceptors which is last in the list will be like called first, and then we will like go backwards in the indexes and until we get to the zero index. Yeah, I mean this is easier for like the folks wanting to override this, so they can add interceptors to the ones that are existing. So you may have like in the main controller that's not that does not have a knowledge about all the other interceptors, and the new ones could just add on top. So that's the reason why I like added like the reverse order. So we don't have like frequent reshuffling of the indexes. So if a new interceptor would like to override the older ones, like it would be like on the zero index, and we would see like the reshuffling of indexes. And to me, it seems like it would be better to track this in the reverse order. Yeah, just like if you have like any opinions on any of this, just like feel free to interrupt me and just say what you think. So okay. And yeah, okay. So this is the scheduling part that I will get to this later. Let's first go through the simple changes. I renamed the interceptor class to the interceptor name. So like we had a feedback from Tim Hawking that the class is we might just call it name. It's much simpler. And but I mean the requirements for the name are the same. So we expect the subdomain. Uh, I also received a good feedback from Doug about the like cancellation policy. So we will have the forbit policy not be revertible. So the forbit policy specifies if any interceptor starts like irreversible change due to the eviction. So it might shut down some it might already start terminating the pod in some regard, and it's not possible to recover. Then it might signal this by a 4-bit field to the status. And we had like original version that other interceptor following this could revert this to allow again. But this might not be handled well by the original interceptor who put the 4-bit there. So the 4-bit is not revertible at this time. And if we need to have this nuance that other interceptors should be able to override it, we will have to bring another cancellation policy. So this is like to be done if we need it. But for now, it will be yeah. So like, I mean, the changes are mostly to make it more like all the changes in the cap are to make it more straightforward and more like to have like less nuances or have like stricter behaviors or validation. Okay, these three things are, we don't have to go through these. Okay, so graduation criteria and workload API. So let's first go to the workload API. Okay, here. Okay, so as you know, like in 135, 6 scheduling came up with a new API called workload. Or I guess not everybody knows, but it will be announced soon. So this like gives us ability to schedule like a group or a gang of pods, like in as a one-shot scenario. So like the scheduler will schedule these basically at the same time. But the workload API has like much more potential. It allows like a set of pods to be grouped under one object, one workload object. So if we have like issues open to introduce this for existing like controllers, for example, for the deployment stateful set. We will see how that goes, but the plan is that like every workload in Kubernetes should be able to like be described through this object, through the workload objects. Like I guess in the beginning it will just like um, just tell us like the current behavior, for example, for the deployment state process, and it will not have like any breaking changes, but it will allow us to basically like handle all these workloads in a generic way, which was not possible today until today. So like we did have like some extension points, like for example, uh, uh, for the scale API, for like if we want to scale a workload, like we could, like for example, if you have a CRD, you could implement the scale endpoint, and this was like very like limited extension. That was generic, and but this will allow us to like define concepts that are like spanning across like multiple workloads, and for example, a kube scheduler can use these, and we might be able to use this as well. So uh, like eviction request was originally meant to target only pods. But we see that with the workload, it might be a good idea to target a set of pods at the same time with the eviction request. And this, of course, depends on the application. So like my proposal here, it's a short proposal, is that we would have toggles on the workload API that would tell us that we could take observe and creating the eviction request, and it would tell us how this workload wants to be disrupted. So if it is per pod disruption or like pod level disruption, which is like the normal behavior, we would just allow any disruption of the pod if it is part of the workload. But if it is like a group of pods that wants to be terminated at the same time, this should be described in the workload. And if somebody wants to evict a single pod, it would not be possible, and we would evict a workload. And by evicting a workload, this could be done as like basically triggering eviction request for all of the pods of the workload, or like during the partial workload disruption, for example, when you have leaders and workers, you might handle like different kind of disruption for each set of pods. So a workload is not, it's basically a groups of pods. So you have an ability to like model more like complicated workloads, for example, like a leader worker set, which has this leader and worker dynamic. And like I guess in the future it might allow us to describe like more complicated applications, and each different application might have a different disruption model. So we could, like after eviction request is merged, we could use the workload API to introduce these like new policies for disruption, and then we would just use the reference policies basically. So that's like the plan. Yeah. Any questions?
So is it your plan to have the workload supported as part of this KEP, the 5363? Is that what you're getting at here? Like this is what we want to have,
Oh
the
yeah, I
eviction support for the workload?
forgot that part. Yeah, thanks for mentioning that. So as I said, like we want to streamline this KEP as possible, as much as possible. So we have to like at least draft the plan for the future. But we decided not to support the workload API in Alpha 1. So I have it in the KEP above in the admission parts. So we will not allow admission of any eviction request that has a pod that's part of the workload. So in alpha, if it is pod is part of the workload, it will not be evictable. And we will revisit this in like later stages of the API and add the workload support. So we can have like either a separate cap or like another pull request to this cap, and we can go through this problematic in a much better way or a more like detailed way, especially because we need feedback from SIG scheduling. So I will take this to SIG scheduling to ask what they think about it as well.
Okay, makes sense. There is a cap. I don't know if you've seen it, like the work with SIG scheduling is looking at like the very basic functionality of eviction for the workload. It's like in the sense of like priorities, like in a few of things. And so there might be an integration point there. I can send you the cap if you haven't seen
Yeah,
it.
I saw one. They have, I think, two relevant caps. I did not have a chance
Okay, yeah, I just
to
wondering if
go
you're
through
aware of it.
these. Yeah,
Okay.
I know. There is one cap which is for workload preemption. So they basically are looking into what how the preemption should be done if the pod is part of the workload. And the other cap they have is for extending or adding a support for pod disruption budgets.
Yeah,
So
makes sense.
yeah,
Yeah, I was gonna say my reason for my mentioning it is that so we're not gonna do, like you said, we're not gonna do the workload API support in this cap. So maybe maybe this is what you're thinking, is that we can kind of like start, laying the foundation for this in those caps, and then we come along later and in the next iteration, and we try to do full support in the eviction request API in like another release cycle.
yeah, yeah, exactly. So I think like this is actually a good coincidence that the workload API came just before us, so we can like handle it well in our cap. And yeah, and it basically gives like this is like we had like a couple of discussions if we should make this API generic, and we did that, so it's not difficult for us to support it. So you basically add a new target called workload ref, and you could have a pod ref or workload ref. Yeah, and the other topic for C scheduling that we have to also discuss with them is the preemption. And yeah, so we have to look at how we should handle preemption for like eviction or for like if the pod has interceptors. So currently, uh, preemption has like a bunch of like checks or uh, like sorting which pods should be like disrupted basically by a delete call. But there's like a couple of nuances. One of them is, so I mean the basic one is like that the lowest priority pods like should be disrupted first. But one of them is like if the pods are part of a PDB, like the preemption logic will look at the PDB if it will be disrupted, and if it has like a better pod, it can choose that one. But it is like a best effort only. So the PDBs are not blocking preemption today, and like because fully blocking preemption is a very difficult topic, and I guess you have like workloads that have like a very high priority. For example, the like the node critical or like system critical priorities, and so you have very like high level critical workloads that should run like under like every circumstance. So if you have a low priority pod that has a PDB, uh, the priority should win over this PDB. But that does not mean that uh, yeah, so basically there has to be some like reconciliation of like what kind of workload is more important. That's what I want to say. And that's like it tries to handle the PDBs, but it cannot fully do that. And to be backwards compatible, like we cannot just use our interceptors and block the preemption for hours or days until like the lower priority pod gets terminated and a new higher priority one can run. So like what I'm thinking was or is that we could add like a opt-in behavior. So we have like a preemption policy field on a priority class or pod. I actually have it here. Okay, okay, so we have like a preemption policy, and now it's like for either lower priority or never. And we could add like a new preemption policy that would say like a lower priority but with interceptors. So it would try to preempt this pod, but it would let the interceptors run. But this would be opt-in. So if like a cluster administrator or like the person as deploying these workloads know that they, even if they have a higher priority workload, they are okay with this higher priority workload taking their time, then we could opt in into that. So that's what I want to draft as a proposal for extending the preemption. And the second part is also the observability. So as like we got good feedback from Eric Tune on the cap, and he said that with PDBs we can observe them statically or like through the API to see like how many pods it has healthy or how many pods it doesn't, and the preemption can like rate this and sort these PDBs and use this information to choose the right pods for preemption. And we want this static information as well for our case to actually have some like predictive behavior, how the eviction request will happen or how it will execute. And currently this is only done through the status of the eviction request. So I will just go quickly through these fields. And during the eviction, when an interceptor is selected, it should fill in these fields. So it should fill in, for example, the expected interceptor finish time, or when it completes, it should give us like messages or conditions how the interception or the eviction is progressing. But we don't have this information beforehand. We don't know how the interceptor is planning to do this interception, if it will be fast, for example, if it will just store some logs from the pod and the logs are short, maybe like a few megabytes of data, or if it will take like a huge amount of time, if it just wants to migrate like a huge database to some other node, and it will take hours. So we don't have such information. And obviously, this would be great to track it, and the field we should track it in would be on the pod spec in the interceptor before even the eviction request is created. So we should decide how each interceptor should present themselves. And one option is to add like the expected finish time. So each interceptor would just tell us, okay, I think I will run 10 seconds or 10 hours. Or we could add like some like weights, I guess. So for example, some values from 1 to 100. Yeah, so this should be required. So each interceptor should give us this information, even if it cannot predict it well. It should at least give us some information. Yeah, any thoughts about this? Okay, yeah, I guess this is mostly important for SIG scheduling because they own the scheduling bits and the preemption. So they are interested in that. So I guess I will add this section about the preemption to the cap as well, and we will discuss it in SIG scheduling. So if you are interested, please join there as well. Yeah, so this is mostly it. I will quickly go through like the changes in the graduation criteria. So I added Alpha 2 and where we will like consider the different kind of orderings, as I said, and like evaluate the relationship between the eviction request and pod deletion, like which is a difficult one, as we can see with the preemption. It's very hard to actually force the use of eviction request on pod deletion, so we will have to at least evaluate it and show like what what kind of changes we might be able to do and what kind of changes are breaking changes. Okay, and in beta we added the workload support. So like to me it seems like we could add the workload support even in alpha 2. So let's see. The same thing I guess is about the immutability of of the interceptors. We can decide like once we have the alpha, we can decide like what kind of these things are the most pressing ones, and we should get more like feedback on this. So this is just like a rough plan, what we plan to do. Yeah, so I guess that's all from my side. Unless people have some questions. Yeah, I've just say this like quick plan. So I will add like a few more updates to the cap, and hopefully we can start with reviews soon and have a good plan to proceed with that in 136. So we should bring this early to the reviewers and to Signode, and hopefully we can make the least feature or the easiest path, or take the easiest path basically with the API and then enhance on that later. Okay, so let's go back to Ryan. Like we had a pretty rich discussion last time we were here, and
Yeah,
maybe
can you
we
give
can.
me the share permissions?
Yeah,
I'll share
sure.
again. Thank you. All right. I guess I figured this get the share sorted out. The context for this discussion, we had it last time. And so we're going to continue the discussion. We may continue it for even a little while longer into the new year. But the context for this is that we went to KubeCon, several of us went to KubeCon, and had some good discussions. Specifically, Philip and I were presenting, and we had some good discussions with the maintainers about doing node maintenance and about maintenance in general. And we learned quite a few things the about the perspective of like what a node is. That was like really a big question that was asked. And so a lot of things kind of came out of that in terms of like, how should we reconcile the designs that we currently have and sort of find ways to integrate beyond just a node. How can we do lifecycle management in a general sense? So that's sort of the open question, and trying to like, so what we're going to talk about today is like uh sort of like what is go through some diagrams, but like kind of what could be uh like a way to look at lifecycle management in the general sense. So from one of the first things is we're going to do a follow-up from last time. I want to go to like the most basics forms of lifecycle management and kind of just review this for additional context. So, and also talk a little bit about the problem, at least as I see it. So if we do today, let me just zoom in a little more actually to see if this is too much. Let me go back up. Okay, no, I can't go anymore. All right, we'll go with this.
That's fine.
All right. So, okay, so this is a picture of a simple drain. The top is the actual work, right? Like this is when I'm highlighting this as kubectl drain. Your admin, you're going to your laptop, you're running kubectl drain. That'll eventually coordinate the node, and then it'll, you'll eventually have all of the pods on your node will get delete calls from them. And that interaction is pretty common. And there are several challenges with it. And this was one of the ones that I talked about at KubeCon, where like, what does the ecosystem look like? If you were an admin here doing this, um, how is it that like how is it clear to everyone else like what you're doing? And there's lots of answers to that questions, and actually the community has done a nice job of answering them. In fact, like we've done it so well that like there's so many solutions that exist out there. So what for specifically like what I'm interested in is like, well, we have all these great solutions. However, there's really not much integration between all of these solutions, and why is that? I think the biggest challenge is that if I was, for in this example, to go through and say, look at the state that I'm putting on the node here, right? I'm essentially coordinating it and then I'm draining something. It's really not clear what I'm doing. You can see the node is cord and that's observable, but it's really not clear like exactly what's happening. I mean, there's a delete call, an event gets sent out, and it's going and deleting pods, but it's very unclear exactly what my intention is and where am I and in what state I'm in. And so that's what makes it so that we end up taking a lot of that state and we putting it into a lot of different things, and then all those different solutions that we end up with are kind of what you see here. And so I guess what I'm after is like, how can we make it so like the ecosystem is a little bit less fragmented, and how can we make it so that with my intention of doing something like a kubectl drain, as simple as that, we could see exactly what's happening, so that tools at very large scale can understand also what my intention is, and can also participate and coordinate together. Um, and so that we can have some cohesion in the ecosystem with these tools working together, and that'll be important for a lot of things later, and like enabling large scale maintenance solutions. So that's my intro to this, is that there's just a lot of fragmentation, and I'm looking to see if there's a way we can address that. All right, everyone okay for me to move on, or do we want to talk about this for a minute? Okay, I don't see any
Yep, you
hands.
can
Okay,
go.
yes. Okay. All right. So I added a bunch of things. I added some writing. I'm not going to go through the writing. I'm just going to go to the diagrams, and I'll speak to some things. All right. So first things for the people who are last time, I've made some name changes. Again, I'm not sold on or tied to these names, but there just seemed to be at least a way that we can that can further illustrate exactly what I'm trying to do in the relationship between some of these objects. So the first thing is so from the top, I have what I've proposed here is a very similar architecture to the PVC architecture or the DRA architecture, um, where you see objects that are declare their intention, and then you see a binding phase, and then you actually see something like a driver acting on that claim, and actually carrying out work. Very similar architecture, and what I've done is I've adapted it to the life cycle perspective. And so why did I do that? One of the big problems, like I said, is the fragmentation in the ecosystem. And so one of the big goals I'm looking at is how can we take some of that fragmentation and how can we make it so that we could have cooperative pieces, or even just APIs that describe the different aspects that go into a life cycle. And so what I have here is this diagram, and I'll go through it at a high level. Is that pretty much what you'd see is an admin would create this thing I call a lifecycle chapter, and what you'll have inside of this thing is your intention. It'll be a specification of a complete lifecycle transition, so a start to an end, and over a time period and in a defined location. So it's effectively our desired state for some sort of some sort of life cycle that we want to occur on, in this case, on a node, and needs to occur within 12 hours. So you declare that intention. And the idea here is that there would be, I said, the binding phase, something that would actually go and a way for you to enact your intention. And so what I have here to pictured is that an admin would create something called, or a user would create something called a lifecycle claim. And this is again very similar to you'd see like PVC, where you create this claim, and it's this claim refers back to what the lifecycle chapter is, which is that declared intention, and it has also in it some state, like a claim status, whether it's been claimed or not, and then it has a driver. And once you have this specified, the idea here is that the kubelet has acknowledged that and claimed this this object, and so it will go and contact the driver and ask the driver to actually act on this claim. And so again, like this is exactly what the CSI interface does, and that where you have something like a driver. Now I'm on the right side of my mouse, where you have something that registers with the kubelet, and this thing is responsible for doing some sort of life cycle, whatever it is, some sort of life cycle operation. And once it registers, the kubelet is aware of what its capabilities are. And when the kubelet does a claim on some sort of life cycle claim, then it would send to it what I have here. I call it a start chapter. So there's two. I've said there's two life cycle events. There's only going to be two, and the start signal is just to tell the driver to start its work, whatever the life cycle event is. And then when the life cycle driver is finished, there's an end to it. And then all this gets captured in the kubelet, these events and this interaction with the driver, and it gets captured by publishing this to the node. And I have this depicted as a condition on the node, and a very specific condition. I'm not really tied to this design particularly. I mean, we could always do this as a condition. We could do this as a status. We could probably do this in lots of different ways. I don't really know, but the whole idea is that you can see the observability getting published to the node as to precisely what's occurring. There's some things that are not solved in the design, and I haven't listed here. And I think those were some questions for last time, is that I'm not solving in this the high-level scheduling for these claims. Like this absolutely deserves some more design, and I've thought about that a little bit, but we probably won't get to it today. But the idea is that these claims need to be scheduled in some way. It probably wouldn't be an admin that would do this. And then what's also not solved is that an election between multiple claims. So like the problem here is like, what if you had like 4 of these claims? How does the kubelet pick one? Something I'm not solving here. So I'm basically assuming that there'd be one. And then some sort of API that is for multiple lifecycle chapters or claims. So again, the same kind of theme where like we'd want to encapsulate a larger plan, because essentially a chapter here is 2 states. And basically these 2 states are for tracking drain. But we all know that doing like node maintenance is much more than that. There's several states that we would need to go through. So I would expect there to be several chapters and several claims. Something I'm not solving here, I would expect that to have its own API and have its own interface. And but so something I consider out of scope. All right. So are there any questions about this? Any thoughts? I think Philip, you had some last time. I have a sequence diagram below. Would that help we go to that diagram, or do you want to go through some other points in this diagram?
Yeah,
Or do you
I
have any
guess
thoughts in general?
I think it might be better to continue with the sequence diagram, so we get like a more better picture, and then we can
Okay.
discuss.
Okay. All right. Let's keep going then. Okay. So what I'm picturing here would be like how this would look with they call these the lifecycle APIs with a kubectl drain. Okay, so all that means is like I'm basically taking. I actually have it pictured here. Server side kubectl drain where my mouse is, and this driver, this lifecycle driver. My expectation is that all it would do is just run kubectl drain, and it would run it from inside as a daemon set and pod on a node. So that's all I mean here by kubectl drain, and that's differentiating from the first diagram I showed where it's running on the laptop. So the sequence diagram would be like this, where first we're registering, we would need a lifecycle driver to register with the kubelet. So this kubectl server-side drain driver would have to register with the kubelet. The admin would create this lifecycle chapter. That's our lifecycle chapter is our declarative or description of what this lifecycle is. And then it would have to create a claim, which is that it's declaring its intent to allow us to do a binding phase. And then kubelet would have to claim it. And then kubelet, after it claims it, would send a start gRPC call to the driver, and it would also update the node with that with whatever the start that start event was. I think I saw a question, or was there a hand raised or something?
Yeah.
Yeah. Hey, Ryan. I'm not sure if you kind of covered this earlier. So can you talk a little bit about why kubelet is kind of considered for this registration and not something like the kube API server? The reason I am asking about this is because at the end of the day, you register with kubelet, but then the kubectl thread will end up talking to the kube API server, right? Which means that now we have a daemon set with a lot of permissions on every node. Kind of. Does that make sense?
Yeah. So the reason I'm looking at the kubelet, so there's several reasons. One of them is that this mechanism of actually binding using the kubelet actually to essentially what I call election, where it's the kubelet is actually handling election for us, and because there's sort of this problem where if you have many claims, right? For example, you need to be able to you need to figure out like who is actually operating on the node, like what controller is doing it. So that's one of them. So we can do election through the kubelet and then using this gRPC mechanism like we see with PVCs, that you can send events to a driver. And then secondly, the ecosystem side of this, because we can define a gRPC interface like through the kubelet, it's much easier to basically express like an interface that any sort of driver can come along and interact with. And so it simplifies a lot of actually the heavy lifting where we see now in the ecosystem is that so much of the I guess you call them like the lifecycle projects have to define like their interface with the node or the pod, and that interface can be different than every other one. In this case, we could define it over gRPC. And then third, there's the kubelet itself, the permissions. The kubelet already has permissions to write to the node itself. And so my expectation is like when it's right here, like step 6. We want to publish information on the node as to precisely what's occurring. The kubelet already has the ability to do this. If you wanted to do this through a pod, you would need to have very high level permissions to be able to do this, and it's not something you see very commonly to allow controllers to have updates permissions on nodes. That's another example. That's another reason for this. So Lilith, does that answer your question?
Yeah, it does. It does. Thank you.
Yeah, I think this still needs a discussion. But yeah, I don't know if you want to finish your presentation or we can return back to this point.
I have an alternative design. Yeah, so we had talked about this, which is like where we don't go through the kubelet. Like, what does it mean? So I have another diagram for this. But just to explain, just to answer that question. That was my reasoning for thinking about it. But we'll get to this in alternative design. There's some discussion points we can have there. Okay. Okay, let me continue. So okay, so I think it was on 5. So there would be some event that you've registered in the chapter. I said the start event, and that would mean that there is that's going to be controlled by the driver. That's going to actually implement that, exactly what that means, and then the kubelet's going to post that some sort of information about what the state is to the node. And then my expectation is that 7, right? So I said this is the driver is implementing what I called server-side kubectl drain. So the actual drain occurs at step 7, and then once it's done, we have an end state, which is going to signal back to the kubelet. And 9, the kubelet would update the node with the state. Okay. Any questions about this? I'm happy to go. We can go to the alternative design if that's like something that's a lot of interest to people as a comparison.
Yeah, I guess maybe
But
we can return back to the kubelet question since we have the context. Like to me, it seems, even though, like you said, like you have your reasons why you want this to be there in the kubelet, it has some advantages. I'm not entirely sold on that because, like, when you look at the PVCs and the DRA, it solves like the like device management problem that are collocated usually on the node. And that's why it makes sense for them to run as a daemon and for the kubelet to have like direct communication channel with by gRPC on the same node. But since we are talking about like a life cycle of the node, but usually in terms of life cycle of like a set of nodes or like a set of like as we said, it might not be even nodes, it might be like some kind of resources. We have to like collaborate and basically handle like the orchestration of this like disruption across like multiple nodes. And so I guess if you have each daemon running in each node, it doesn't like particularly fit into this scenario. Like as we like discussed last time, this has the advantage of handling like the disruption or termination of the node if you are in a like disconnected environment from the API server or like you have like network issues and but to me it seems it would be better to solve this solve the main like or major problem like which is like the uh, cluster-wide orchestration and maybe focus on the node part like after that. What do you think, Ryan?
I think so there are challenges. So we can get to it. I think there are challenges in the cluster-wide orchestration. And like specifically, I think a lot of the challenges come from like how do we come up with like the right solution in the community? That's like super, I think that's hard. At least I haven't quite been able to figure that part out. Like I think where I'm going with this is actually um I look at this sort of as um the kubelet as like our integration point, and I look at it less like associated with a node or actually with any Kubernetes object. Like the target here is almost like we want a driver to be wherever a kubelet is, and if we can plant a driver there, then we have the ability to we have sort of the building block to do any sort of coordination that we would want to or we would need to. But like for me, the way I'm thinking about it is that that was to me like in this diagram, like I have it here, like I consider it to be out of scope. Like I think people would build on top of this architecture, and they would build the um, what I call the lifecycle controllers down here, because they have here all of the APIs they would need to fully coordinate whatever the lifecycle event or whatever they needed to do, whatever coordination they need to do across nodes or across objects. Um, so that's how I look at it. Is I feel like that is a challenging thing, is it because it's very end user specific, at least in my mind. Um, but I'll think about it though. I mean, maybe there's a way, but I'm still haven't come across a way to handle this kind of orchestration without
Yeah.
like some of these building blocks.
So yeah, I guess in some sense, like this, like um your model, like it makes some sense in some scenarios, but if you look at the from cluster-wide perspective, so we basically have to solve like the extensibility and coordination. And like even here, like it's not completely like pronounced. So we don't know like the lifecycle controllers will interact with the driver, how, as you said, like the election question or like the coordination question is still not solved here. And I guess it's, to me, it seems it's very hard to do it through kubelet, because if you have a controller outside the node, like wanting to interact with that, you still need to go to the API server and publish it. So I guess like even though you will have more challenges through the coordination, like once we want to introduce such extensibility, I guess we could like start with the driver. But once you want to introduce like extensibility and coordination, we will have to solve like these hard questions like eventually.
Yes, I agree with you. Yeah, I guess what I'm trying to say is I fully am aware of the problem. I actually I think that what I'm saying is that I'm having a hard time getting to that coordination problem without having some of the building blocks. Like my feeling is that we're missing some things, some bunch of building blocks here. Like particularly like what I'm picturing, like where we have this we have states and we have objects that have declared in current state or the desired and current state um and having like all the API objects that can explain like who's working on it, what's working on it, what's being worked on, is seriously lacking, and that's what I'm targeting. It's a building block, and I absolutely think there might be a world that we can get to that coordination. Um, but yeah, it's not what I'm targeting here. At least not yet.
Yeah, I mean, like the good idea is like capturing the ownership of the life cycle, uh, like chapter or like other like or claim or like yeah, last time I used other terms as well. I don't remember them all, but uh, like yeah, we have to capture the ownership of the event of each like the chapter. I guess is could be like split like into these like steps, and like we should be able to coordinate like who is implementing what.
Yeah, yeah, I agree. I think like yeah, I think like the challenge is like so um yeah, the
Yeah,
challenge is like the building blocks. Yeah, I
yeah,
think that at least that's where yeah. Sorry, go ahead.
yeah, sorry. Yeah, I think even if we want to go like through kubelet in the end, I think like we probably should not focus on it, because we can design the API like in we need to design the API how we want these interactions to happen. And if it makes sense to put them kubelet, we still can. But like all this like coordination, who is like executing what part of the life cycle, and how it is presented. So I guess on the node, like we can fiddle with like how it will be like expressed. But I still feel like because to me it seems like everything should be presented on the API server. And if we have only like some part of that like just handled between kubelet and the driver, like my just uh I don't have like I don't see into the future, but to me it seems like we will run into the problems like if we do not have this all like tracked in the API server, especially since we have all these components trying to interact with that.
By tracked in the API server, like what is what you mean like that we need to have something that's discoverable, like some sort of discoverable state as to like what's like the current state and what the driver is doing
Yeah,
in this
because
example, in this context.
yeah. Yeah, but yeah,
Okay.
that's still usually the main problem is like if you don't know what's happening on the cluster, you don't have a good way to debug, for example, the drain or uh, like yeah, like we have some scenarios like as is the graceful no shutdown that's basically implemented by kubelet that would benefit from this flow because since it's collocated already, it would be pretty easy to switch to this. But like in the other scenarios, like yeah, I still don't see like the North Star why we should run like each node should run like a daemon for for the lifecycle events.
So the okay, yeah, I think what we like what you're saying with the discoverable in the API server, um, yeah, like so that was also my intention here is that we I posted on the node. Maybe this is maybe you're thinking it would be a little differently, but that's how I was picturing it here is that the current state from the driver would get posted on the node, but we'd be very explicit about like what those states are ahead of time. Like we wouldn't allow the driver um, to like post any state it wants. It would just be it would be defined in the chapter. Like there would only be two, and it would make its way to the node. So I wasn't sure. Is it like when you said the API server, like it needs to be its own independent object outside of the node? Is that what you meant?
Yeah, I think like I will not uh, delve on the implementation details. I mean, like what kind of problems we will run into when we want to express this on the node on the resource. Like I think if we just can express what we want to do, like the intent, like without like the implementation constraints, like just uh, show the interactions and how we want to like coordinate them. And then we can go back like to the API, like what's actually feasible, what we express, what we could express on the node if we need an additional resource. Or I know like some people are like proponents to having like a call it like a sub resource API on the node. So we could have like a special sub resource that would should be called like to set some things on the node object, and it would have like better validation or like permissions. So like there are ways to do things, but I think like we still need to start like from like the higher level perspective what we want to do, since I guess the most important ones are the coordination and the extensibility.
Yeah. I mean, I can go real quickly to like what I have for the alternative. And maybe this is what you're picturing. Um,
Yeah.
this looks similar to the to like the declarative node maintenance API. So one important thing I did do here is I took the states out of them. So I okay. So here one of the challenges here is that these states that I have like internally on the maintenance API, there's sort of an issue here where like how do we make these states extensible and usable in all forms of maintenance? So not just to node. I This is what I'm struggling with. Um, so I picture these here as just so you can see the interactions between these states, but they're not actually on this maintenance API. This thing pushes them to the node. This maintenance API publishes them on the node instead. And like I said, the reason for that is I don't know how to model maintenance in the general sense, like beyond a node, a pod, or anything. Like there's like cordon would not work. Like there's several things that I'm having a hard time with. And the other part about this is, I guess, like extensible. We would have to come up with some sort of finite state machine for this, and the extensibility of that would be a little bit limited. We wouldn't be once we decided what it would be. It would be difficult to extend it. So that was kind of what I'm thinking here. But this is what the how it would look is that it would be something like this, some sort of centralized API for maintenance. Um, I still think you have to post those states on the node. I don't know a way around that. And then it does like the coordination where like we're having using the interceptors, like we're creating an eviction request um, and then it does the drain.
I think it's like interesting like direction to take to try to like split them from the maintenance API and make them extensible or definable like in the API like on the fly, or like even before the drain happens or the maintenance happens. Yeah, we are almost, or we already are at time. So
Yeah, we're at
yeah,
10, but
yeah, I know.
yeah,
Like
that
it, just
sorry, go ahead.
yeah, please go. Yeah, like we can give it like a few more minutes. But yeah,
Yeah, I'm happy to discuss if we have a few more minutes. But I think that this is the challenge. I don't like so it could be a separate object. We could create a separate object here or something and define and allow basically allow people to to express like what are the states that are going to be then passed to that object. Yeah, I that's a possibility. Yeah. So it'd be
yeah,
like I don't know, we call it like maintenance states or something. It would be like another object down here. And this would have in it like idle or and drain maintenance. And then you might have another one for like a pod or something.
yeah. Like we need to handle like who implements what, since like the first iteration should be like that we have the implementation in the core to, for example, handle the drain, and it would work like seamlessly. But we should be able to like override these to uh, basically like all like bigger companies have their own scenarios for the maintenance, so they would override this and add their own controllers or logic. So
Right.
I think it's a good direction to take. I mean, the maintenance API is it's like we will discard that cap, but like we can take some parts of that that could be useful.
Yeah, but I think, but what you're thinking though is that we have a resource, a centralized resource for coordination, like a that's what you're after, right? Which would be like what I'm calling the maintenance API here.
Yeah, I would
The,
describe it as like dynamically creating a graph of the maintenance by all the controllers. Like we can
so it's like
define,
it's yeah, go
yeah,
ahead.
like we can define, like for example, what kind of states or phases we would support, or however you want to call it, to have at least some like predictability. But for example, you can have like you could like in some company you could have like multiple ring controllers that you want to run at the same time, right? So you could have the claim for to drain like to multiple components, and but you need to track all of this somehow. So like we need to make the case like what we want to achieve, and
Is the expectation that all those different controllers would be like essentially publishing a status to that shared
I
uh
mean the first problem is that you need to have the definition even before you run the drain or the
right,
maintenance.
right.
Because like the observability is very important before all of this happens. So we need some kind of mechanism of advertising to like what will happen like when you run the drain or how you will simulate it.
Yeah.
Yeah, and the next step is like posting the status of what's happening during each like phase or status or uh, yeah, and I mean to me like we don't have to solve the implementation details how we want to represent it. Like we can just do, you know, yes, as you have it here, like idle cordon drain maintenance, and if you know what you want, like how this should be claimed, how it should be like represented or like advertised, and then we can like try to narrow it down to like a clearer APIs.
Yeah. Okay. Okay, that makes sense. And then I think the other yeah, so this is all coordinated through the maintenance or sorry, through the some sort of object and then right, and then we can and I can extend it. I don't know like what I don't know what the feeling is on this interaction with the node here. Like when I show like states being published on the node, we have to publish state somewhere. That's the still I'm not sure about this one. My sense is it has to be on the object that we're actually doing like lifecycle on, and it can't. But so this thing on the left needs to be our plan. That's at least how I'm viewing it. It's like our desired plan, and then the thing on the right is the thing we're actually working on. So I don't know. That's another open question.
Mm, I think it's good to focus like what kind of information we need to publish. Like one of the like things we have to be careful about is like the scaling part. Like the node object itself cannot store like a unlimited amount of information. So even if this is extensible and you have, for example, like 100 of drain controllers and each one of these is like publishing lots of information, it like we will cap we have a cap on the node how much data it fits there. So yeah, that's just one consideration.
Yeah. Okay. I mean, so these are, yeah. I mean, these are the things that I listed as not solved, but we can continue to think about. Yeah. I think like it's like I just said, like the heterogeneous part. So it needs to be general. We need to figure out election in this model. So we need to express ownership. That was the way that another thing we have to have. We have to decide a way how we do ownership. Um, I mean, we can overcome this, but you would need to have this thing would, in my opinion, it needs to be able to post on the actual object that we're doing it. And then we need a way to express maintenance in the general sense, and it needs to be able to, the order needs to change and it needs to be able to expand. So these things could technically come in any order, even though I've got arrows between them. You could technically choose the ordering of these things.
Yeah. Yeah, I think like it's also good to like to focus on the prediction and simulation in the beginning to see how we can describe it before we run the maintenance.
Yeah. Okay. Let me take the feedback and expand this diagram. And then we can do another comparison to what I have earlier to this. And I think like I want to go back to this. I can look at this without the kubelet as it could be the API server and see how people feel about that.
Yeah, would be great.
Okay. All right. Well, I think we'll talk about it in January, but I'll post some updates before then. I think I'll be able to get to that. And we can review in a thread in the Slack channel.
Yeah, sounds fine. Thanks a lot for iterating on this.
Sounds good. All right. Thanks for the feedback.
Okay. See you next year, everyone.
Yeah. Happy New Year. Bye.
You too.